So here's just summarizing what we have so far in the center of mass of this particular shape that we've been looking at. And so what you should present for your project doesn't have to be a lot. So we just want to say, what it is, what the functions are, the intersection points, however you calculate those, presumably using a calculator. I'm assuming you do all the integrals by technology. But we do want to clearly indicate X bar, Y bar, what they are. So it would be nice to add the center of mass is negative 0.196, comma 2.156. If you didn't put that in, it's probably fine. It just occurred to me just now that would be nice, but we know what X bar and Y bar are. So it just sort of shows how we came up with that center of mass. So we want to show the integrals using your functions from that general formula that we talked about. Okay, so then the next thing, so here comes the fun part. So now you're going to print out a graph, right? So you print out a graph, and you're going to get a piece of cardboard. Is the easiest thing to use. This is just a piece of corrugated cardboard, right? We're all getting tons of stuff shipped to us right now, right? So there's tons of boxes. Maybe that's wrong of me to assume that because maybe some people aren't. But I'm getting a lot of stuff shipped to me, and it comes in cardboard boxes. And what are you going to do with all that cardboard besides take it to the recycle? Well, you're going to make a shape out of it, do a calculus project. Okay, so I already did one of these, and what I found just worked fairly well is you can be creative. There's lots of different ways to do this. So I just found something that works. So what I did is kind of crazy. I just stapled this puppy on here. Staple. All right. Now, I wouldn't want to use staples as my ultimate securing device because they have non-zero mass and they might affect the balance because this thing's very light, so it's going to be pretty sensitive. All right. But the idea is just to, these are going to be, the staples are in areas that are going to be removed anyway. So it's just to hold it put for now. By the way, something else that I did that's going to be really important. We have a grid on here, right? This is just a Desmos, standard Desmos print. We have a grid on there. By the way, if for any reason you can't print a graph, just send me an email. There are ways that you can do these without a printer. It's just a little bit more work, but not impossible at all. All right, so what I'm going to do is check the squareness of my grid because I got the printer going on. I got, however it was set in Desmos. These squares have to be really square. So I'm measuring from like -1 to 1, and it looks like I got 7.2 centimeters. So if I measure from 0 to 2 vertically, I should have the same measurement. Yep, 7.2. It's right on. It could be a little off. Some of my graphs were like 7.25, or it's off by a half a millimeter. Is probably not going to be a problem. Also, by the way, it is possible that if it's not square, so we do a vertical or a horizontal expansion basically of our shape because the grid wasn't square, it's possible that the center of mass remains at proportionally the same place and it wouldn't affect the outcome. But I don't know, and I'm too lazy to find out. I'm not really too lazy, I'm just not sufficiently curious. So there's a laziness level and a curiosity level, and currently the curiosity level is lower. So I just feel, let's just make it square. Now, by the way, so I have my graph of, this is my parabola, 4 minus x squared. I have my log function here, ln of x plus 3. And then I also graphed x equals negative 0.196 and y equals 2.516. So in fact, by doing that, I know that the center of mass is right at that point right there. All right, it's not at the center, obviously, of the figure, or not at the obvious center of the figure. Okay, now what I got to do is I got to cut this cardboard out. So what I did was I took a very sharp knife, and since the paper is pretty well fixed, I'm just cutting really lightly in. And again, there could be lots of different ways to do this. This is just what occurred to me to do. So I'm just making a very light cut because what that'll do is essentially transfer the image onto the cardboard, and then I'll make a deeper cut in the cardboard. So I'm cutting that way. Now I'm cutting this way. I'm doing this as carefully as I can. Cutty. If I had editing capabilities, I would edit this at this point, but I don't know how to edit videos. I don't have software that will do that. I probably do have software that will do it, like installed on something somewhere, but I don't know where it is or how to use it. But I can wield a knife all right. Cutting through here just like the... Who's that famous barber who killed people? Some kind of... What's that play about the barber who kills people? The musical. Barber. No, that's Mozart. Tom Sweeney, something like that. I don't know. I can't remember. All right. So now I'm going to pull this shape off. Sweeney Todd. That's what it's called. Sweeney Todd. He's the barber who kills people. You got to know these things. All right. So I want to carefully make sure this is detached. So I kept my shape very nice, and hopefully I can see my pattern in here. Yeah. So I can barely see it, and you definitely don't want to see me trying to retrace this. So I'm going to cut this video here, and in the next video I'll show how we're going to put this together.